Allora, cominciamo. Intanto vi do il benvenuto al Politecnico. Sicuramente aspettiamo altre persone, ma pare che ci siano incidenti su Via Mendra, quindi partiamo con i lavori, poi avranno modo di seguire il resto. Allora, io sono lieto e onorato di porgere soprattutto il saluto del magnifico rettore del Politecnico di Bari, il professore Eugenio Di Sciascio, e a cui aggiungo il mio personale, e soprattutto sono onorato di aprire questa giornata, questa tappa barese del roadshow della MAXON, che è dedicata, come potete immaginare, a temi della rappresentazione, anche architettonica, che è poi il tema della disciplina a cui io poi afferisco. E devo dire, posso affermare che questi temi saranno affrontati con sicuramente ai più alti livelli di specializzazione. Colgo l'occasione per ringraziare intanto la GRMStudio, che ha scelto tra le varie sedi Bari e il Politecnico per questo evento. Ringrazio i partner locali, ringrazio tutti quelli che con il loro lavoro, il loro impegno hanno permesso di organizzare questa giornata, ce ne sono qua in aula alcuni. Ma soprattutto ringrazio tutti voi che siete qui per ascoltare i lavori e le relazioni. L'appuntamento di oggi rappresenta un'occasione importante, un'occasione propizia anche per, come avviene in quasi tutti questo tipo di questi incontri, per allacciare nuovi contatti oppure per consolidare contatti già esistenti. Ma io credo che sia importante e proficuo per affrontare dei temi attraverso le relazioni dei esperti internazionali che seguiremo, problemi di grande interesse e attualità che riguardano, per quello che mi compete, la rappresentazione architettonica e che in qualche modo, secondo me, ci daranno possibilità di cogliere informazioni e ispirazioni per il nostro lavoro, ognuno nel proprio ambito di interesse, nella propria disciplina. Il dialogo tra Politecnico e GRMStudio, e quindi la MAXON, è già iniziato da qualche tempo, attraverso il lavoro e le attività del laboratorio del MAULAB, che è il laboratorio di modellazione architettonica urbana del DICATEC, di cui io sono il responsabile scientifico e che ha già dato dei risultati importanti e proficui sia nel campo della didattica che nel campo della ricerca. La speranza e la prospettiva va verso un'intensificazione di questi rapporti sulla base del fatto che i percorsi formativi erogati dal Politecnico di Bari e le attività di ricerca trovano, secondo me, nelle tecnologie digitali prodotte da MAXON un supporto straordinario. Io spero che MAXON e GRMStudio trovino in noi, nel grande comunità scientifica del Politecnico di Bari, un interlocutore utile per sperimentare, sviluppare, sperimentare e diffondere i propri prodotti. Personalmente mi aspetto da questa giornata che emergano risposte alle tante domande che sia la mia disciplina che il mondo professionale si aspettano dalle tecnologie digitali riferite alla computer grafica, riferite alla modellazione tridimensionale, alla realtà virtuale, a quella aumentata, non soltanto nel campo della ricerca, ma anche e soprattutto nel nuovo processo progettuale che, come sapete, almeno credo che almeno i nostri studenti sanno già da un po', perché li tartassiamo su questi temi, sono fondati sugli aspetti prestazionali di un edificio. Quindi, e lo dico insomma anche contro il mio interesse, un progetto fondato non sul disegno ma sulla simulazione. Vabbè, io adesso concludo perché credo di aver parlato anche troppo, e concludo intanto augurandovi buon lavoro e passo volentieri la parola a Vanessa Mercanteboi, che è l'amministratore delegato della GRMStudio. Grazie.
Allora, innanzitutto grazie per essere qui oggi, alla prima tappa del roadshow, seconda edizione. Siamo veramente felici di essere a Bari, peraltro città bellissima, abbiamo avuto l'opportunità di visitarla ieri, era la prima volta peraltro per me, quindi veramente un posto meraviglioso. Inizio dicendo che purtroppo abbiamo avuto un ritardo nel programma, per cui dobbiamo essere un po' creativi. Questa mattina vi chiediamo un po' di pazienza. Non vi togliamo la pausa caffè, però non sarà, diciamo, forse tanto lunga quanto al professor Verdoscia per l'introduzione. Professor Verdoscia per l'introduzione e non so se l'ho già detto, sono Vanessa Mercanteboi, sono dal 2016 l'amministratore delegato di GRMStudio. La nostra è una piccola società per cui ricopro anche tanti altri ruoli e volevo iniziare, diciamo mi ero preparato un discorso un po' lungo, però lo riduco un po' per lasciare appunto posto ai nostri relatori. Allora, GRMStudio comincia nel 1995, siamo i distributori ufficiali di Cinema4D e di MAXON dal 1997 e mi pare che il 31 ottobre infatti segna il nostro ventennale di collaborazione con MAXON. Siamo stati i primi nel 1995, lo dico con certezza, ad importare un programma di realtà virtuale e di 3D in tempo reale. Se c'è qualcuno tra di voi che lavorava nel 1995 con il 3D, sapete di cosa sto parlando, di che tipo di problematiche. Abbiamo dovuto aspettare 20 anni per riparlare di realtà virtuale e oggi, grazie infatti ai nostri relatori, parleremo non solo di realtà virtuale, ma anche di realtà aumentata, di intelligenza artificiale e di machine learning. E questo peraltro io lo vedo anche come il futuro di GRMStudio, quindi il 3D però anche un ecosistema con tutte queste nuove tecnologie. Quanti studenti ci sono tra di voi? Ok, e quindi il resto suppongo professionisti. Quindi voi ragazzi vi troverete appunto in un ambiente diciamo lavorativo dove dovete adeguarvi a tutte queste tecnologie che si uniranno diciamo in questo ultimo ecosistema. Allora, concludo purtroppo il mio discorso ringraziando intanto il Politecnico di Bari per l'ospitalità, grazie veramente di cuore. Siamo veramente felici di questa collaborazione che abbiamo iniziato quest'anno e ritorneremo a Bari. E ringrazio anche il magnifico rettore, il professor Di Sciascio, Riccardo Tavolare e Rita Giuliani hanno fatto un lavoro favoloso ed il team di ragazzi che hanno assistito durante appunto la preparazione dell'evento, i nostri ambassador, oggi c'è Franchi Barletta, grazie per esserci. E vediamo chi abbiamo ancora, sponsor, partner, Maxon, V-Ray4C4D, Fabio Palvelli. Una cosa molto importante, vorrei fare 2 annunci. Ci saranno delle premiazioni oggi, abbiamo fatto un'estrazione di premi, i premiati verranno annunciati durante la famosa pausa caffè. E c'è un cambio di programma. Glenn Frey parlerà dopo Richard Boyd e Riccardo Tavolare parlerà al posto di Glenn Frey. E mi pare di aver detto tutto per quanto riguardava gli annunci. E vi lascio con un video di Fabio Palvelli, che non so se lo conoscete, è un influencer molto importante in Italia, è il fondatore della D2 Conference e anche il portavoce di V-Ray4C4D in Italia. Non è potuto purtroppo partecipare perché si è appena trasferito a Tel Aviv, però ci manda un augurio, diciamo, di buon roadshow e anche dei consigli importanti. Per cui vi ringrazio ancora e buon proseguimento.
Salve a tutti, mi chiamo Fabio Palvelli. Salve a tutti, mi chiamo Fabio Palvelli, sono uno dei fondatori della D2 Conference, una delle conferenze più importanti al mondo nel campo della grafica, soprattutto per quanto riguarda la visualizzazione dell'architettura. Da 2 anni collaboro con V-Ray, mi occupo della comunicazione e dell'insegnamento del software per loro, con base a Vienna. Recentemente mi sono spostato a Tel Aviv, in Israele, ragione per la quale non posso essere con voi oggi al roadshow. Da 2 anni sono entrato in contatto con GRM e mi rende orgoglioso di sapere che ci sia una realtà di questo genere in Italia. Vorrei rubarvi 1 minuto del vostro tempo per ringraziarvi di essere venuti al roadshow e per farvi i miei complimenti. Infatti nel mio caso io sono riuscito a costruirmi una carriera proprio grazie ad un evento del genere, durante il quale ho avuto l'opportunità di conoscere altri professionisti del settore, ai quali ho avuto l'opportunità di chiedere e fare domande, con i quali poi sono diventato amico e eventualmente si è incominciato a lavorare insieme. Vedete, uno degli interessi principali che le compagnie che sviluppano e distribuiscono software è quello di creare le condizioni ideali per i propri utenti all'interno delle quali si possa svolgere il proprio lavoro, e eventi come questi sono il risultato di queste intenzioni. Quindi bravi, grazie di essere venuti, voi siete un passo avanti rispetto a quelli che oggi hanno deciso di fare qualcos'altro e ora sta a voi fare del networking, conoscetevi, parlate tra di voi, fate domande e diventate amici. Chissà, magari potrebbe incominciare una nuova avventura artistica. Grazie ancora Vanessa per l'invito, di avermi dato l'opportunità di parlare alla community. Vi auguro una fantastica giornata e per chiunque voglia mettersi in contatto mi trovate sui social @Fabio Palvelli. Grazie e alla prossima!
Allora, benissimo, procediamo con la presentazione di Richard Boyd. Eccolo qui. A lei.
Allora, buongiorno amici. Ho detto buongiorno amici. Meglio. Sono molto felice di essere qua. Io amo Italia. Io amo le donne d'Italia. No, sbagliato io. Io amo una donna d'Italia. Ha scritto mia moglie la frase giusta. Sono americano, non sono italiano. Capisci? Ok, so credo che è meglio che parlo in inglese. Sono in accordo? Siamo in accordo? Ok, meglio così. Ok. Ho tante cose di trasferire, di condividere con voi. Meglio in inglese più chiaramente, se possibile, ok? All right, switching. See, loro sono molto gentile. She said you'd be mean to me, but you're all very nice to let me speak in English. All right, yeah, first time in Bari, I want to thank Riccardo Tavolare and Rita. Where's Rita? She's still outside? Okay. And of course, thank all of you for coming here today, for the Politecnico, for GRMStudio, for the invitation to be here, and share some very exciting ideas, I think, with you, and you're in for a very exciting day. Do all of you know what to expect from today? Okay, that doesn't seem like there are a lot. That's good, because I know that one algorithm I know is satisfaction is results minus expectations. So if you have no expectations, I guarantee satisfaction today. All right, where's my little clicker? All right. So today you're going to hear a lot about 3D graphics, VR, AR, and some of the other speakers will focus a little more on that. I'm going to dig in a little more into artificial intelligence. Intelligenza artificiale. Who's working in that field here? Anybody playing now with machine learning, artificial intelligence? We'll see if we can't change that. Let me go back here and say, this is a little bit about my perspective. I think perspective is very important. I want you to know my perspective. And the reason I came here, other than the great food and wine and the women and everything, is to understand your perspective. This is my entire career on one slide. So almost 30 years, believe it or not, working in 3D graphics, working in gaming. I don't know if you know some of these games. One of the game companies we built was with Tom Clancy, Red Storm Entertainment. Anybody? Rogue Spear, Rainbow Six. All right, where are my people? All right. It was the first company that created the realistic tactical shooter game. In the early 90s, the games were, like Quake and Doom. They were, you run around, you shoot monsters, you pick up health packs. Nothing that has any real tactical value or anything you can transfer into the real world. And we did this first. Some people said, you're crazy, you're pazzo to do this. No one's going to want to play a game where you can get killed in the first 30 seconds and then you have to sit aside and watch. But we proved that this was a very valuable genre. We sold it to a French company called Ubisoft in 2000. And today this franchise is over $1 billion a year in revenue. So we didn't time that perfectly. I don't always time these things right, but I'm very good at working with teams of creative people like you to create the ideas. We did a game company with Ozzy Osbourne. Do you guys know Ozzy Osbourne over here? All right. That was a horrible disaster. I'll tell you about that later over beers or something. And we did a game company with Michael Crichton, and we've done some work in the movies that I'll talk about. All right, so that's the perspective. As I say, do you guys know Alan Kay over here? Alan Kay is the guy who created Xerox PARC. Xerox PARC is where we got the mouse, where we got the first laptop computer, where we got the Windows interface that we're all still using, unbelievably, so many years later, since 1968. He's a very good friend of mine. I try to collect smart people and talented people around me. I'm looking here today to find some more. In fact, what I'm looking for is who's going to be the Fellini of AR, VR, AI. And I'm going to tell you what I mean by that. All of us, 100% of us, can consume media, right? We can watch TV, we can watch movies, we can watch YouTube. About 10% of us can integrate content and create something new. It doesn't take that much skills with all the great tools we have today to integrate content and create something. But only 1% of us are the Fellinis, the James Camerons, the Brian De Palmas. All of us have video cameras on our cell phones, but how many of us can make, a great movie with that? It takes a lot of skill. I'm sure there are a lot of very creative people here who are among the 1%. And that's, I think, what we're looking for. And in my talk today, I'm going to talk about some of the pieces that need to be put together to help that 1% take advantage of this new medium. Because that's all this is. When you're working with 3D graphics, when you're working with VR, when you're working with AR, it's just another media type, the way the written word is a media type. I know Italians have done a great deal with the written word from many, many centuries back and showed the rest of the world what can be done with that medium. You've done the same thing with art. You've done the same thing with cinema. I'd like to see what we can do now, and I think we're right now at a tipping point where telling stories, telling narrative with VR and AR, there's a whole new opportunity. And for me, it feels like when we created the first movie camera. You may have heard this story before. What they did first, because there wasn't a lot of imagination, they put the video camera on a tripod. And then there was a stage, and people acted in front of the camera. And then someone, probably an Italian, came along and said, let's take this camera off the tripod and let's make it part of the action. That changed everything. That's where we are now. We're ready to see a big change in how this medium is used. So, and just very quickly, I could do 1 hour on each one of these subjects, but I very strongly believe, if you guys know the writer, William Gibson, that the future's already here. We have all the pieces. It's just unevenly distributed. It's about pulling it all together to do something new. So I think the future is mobile, it's aware, it's cloudy, it's going to be served up on not just on single devices, but over the web, over the internet. It is, sorry. I'm walking away. So this has to be here and this has to be here. All right. All right. But simulated, automated. We're going to talk mostly today about automated and simulated. Okay. And like I said, I'll focus more on the artificial intelligence. And this is what's driving it, of course. It's Moore's Law continuing to double processing power about every 18 months, and that's what's creating a lot of the tremendous capabilities in VR and AR, but especially with GPUs. GPUs are working faster than Moore's Law. They're doubling in power, in price performance, even faster. And I'm very interested in following this because I think do you guys know Ray Kurzweil here from the Singularity Institute? He's been talking for a while about this power and saying that very soon for $1,000 you'll be able to buy the power of the human brain for $1,000. But already at the high end with some of the supercomputers we have, I believe we're already there. And in one of my last companies, we were actually working with computers that were, I think, beyond that. So it's a very interesting time to be at the position all of you are today to take advantage of this power. So here's just one example of that. I promised I would talk about this experience, but I'm going to talk a lot about the year 2009. So everybody think about, where were you in 2009, right? That was a very pivotal year, and you'll hear me talk about that year being different in a lot of different technologies. This is one of them. So everybody knows James Cameron. How many of you saw Avatar, right? So I'll tell you a little bit more about my history with James, but it goes all the way back to the first movie we worked on, which was The Abyss. Did you guys see The Abyss here? It may have a different name here, like all of them do. But he invited me out here to see his stereoscopic camera. He's very excited about stereoscopic 3D and the fact that stereoscopic 3D has implications on memory and how humans experience content. And I think that's true. But how many of you have a 3D television at home or a 3D projector? So one. See, that's a problem, right? He was saying this in 2009. It has not taken off. Why? Well, we'll talk about that a little bit. Now, I bought one right away when he showed me what we could do with it in Avatar. So I bought one at home, set up the whole theater, got the glasses, got them for the kids. And we watched about 6 3D movies in the first week. And I think in the last 6 years, we've watched maybe 6 movies because there's too much friction. Too much, you have to charge everything. There's a lot of work that has to be done in order to get the payoff of this experience. I'm going to talk more later about friction in VR, friction in AR, and design challenges we have that we have to get away to change that. But you can see this is me on the set with him and Vince Pace. This is the camera, the stereoscopic 3D camera, where you could set the interocular distance, and he was shooting the movie there and compositing with the game artist the virtual world and directing what happens in that, and also directing live actors at the same time. It was an amazing thing to see. And today, by the way, in the next 3 movies, this is the way the camera looks today. So there's Moore's Law working for you right there, just the size, the fact that now it's very small. But that's not what I was most excited about once I got there. This is what I was excited about. This is a space called the Volume. And if you know anything about this movie, there was no actual set. The only real set was one office and one of the helicopter cockpits. Everything else was virtual. And all the action took place within a very large hangar, and there were sensors everywhere. Over 120 sensors. I spent most of my time in that world taking this little window and walking around in Pandora and watching ships come down and walking through the forest. And that, I just thought that was amazing. And that revolution in that sensor capability I'm going to talk about here in a second, that was the big change for me that changed everything. And the other thing was this motion capture piece. I have a video there. I don't know if you can click on that in the lower right. Yeah.
Digital humans are
I'll let it play. Oh, you can go ahead. I think you guys have all seen this anyway. It's the idea of instead of having to
Digital
animate,
humans are populating movies and video games. Maybe magazines will be next. Check out IEEE Spectrum's article on the digital face by Eric Pavey. I'm Tekla Perry in MOVA's Contour Reality System.
This was actually in 2008. This was a huge breakthrough. Instead of having to wear the suits and all the dots, now you can just have a video camera on an actor. The actor acts, and even without the dots, it can capture that directly in real time into a virtual world. Now, they still use the face capture system on Avatar, but that piece of compositing the real world into the virtual world and putting humans in there so they can act was a big breakthrough, also around 2009. Sorry. And of course, this is where everything is. There's a company in America called Gartner that tracks technologies and says, when are they ready to actually break out and really go mainstream? And right now they say VR is already there. It's past the initial excitement through the trough of disillusionment and now is beginning to be accepted and going more mainstream. But they have these interesting definitions of VR I hope we can talk about, because they include everything like stereoscopic 3D or just having a 360-degree camera. I don't always include that in VR. And I think those definitions are important. Hopefully we'll have time to talk about that. Then they have augmented reality ready to take off, and that's what I'm most excited about, and we'll talk about more today. And then machine learning and AI they have way up here. And I actually disagree with that. Like I said, technologies are already here, the future's here, it's just unevenly distributed. I believe that machine learning piece is all the way down here. I'm going to spend a little more time on that to make sure you guys here understand what's happening, because it is profound and it's changing everything. There's a revolution happening in computing, in design, and everything. And our relationship as humans with computers is changing because of machine learning. But first, a little history. It's very sensitive. I'll give you a little bit of history of how I've gotten to where I am. Do any of you remember this game? So this was the first game we worked on all the way back 30 years ago, 1987, The Colony. This was the first 3D adventure game. And that's the one that attracted people like James Cameron to say, please come out and work on The Abyss. And people like Brian De Palma and others, because of this amazing capability of just taking even a black and white computer and being able to walk around in it as you're building. That was a big transformative thing. Now, the next thing is we made this product, Virtus Walkthrough. And that, again, was a real-time 3D design tool. Very crude, but very easy interface, not much friction. You could get an architect could get their idea out of their head into the screen very quickly and share it with other people. And we started using it in films. Like I said, The Abyss. I'll tell you a quick story. If you saw that movie, it was mostly underwater, right? And it was actually filmed inside of a nuclear power plant in one of the big tanks. Now, it had never been turned on. There was no nuclear waste in there. But what we did is we came in with our very crude tools, and we designed the entire set for James Cameron and the cinematographer. And this was 1988, to show you how long ago this was. And I believe it was even on a black and white Macintosh. And by walking through the set, though, and we made little tools so you could set the aspect ratio for the camera lens and that sort of thing, we found out that a third of the set never showed up on screen. He didn't have to build it. Saved him about $3 million, and we've been friends ever since. So those kinds of real applications where you save real money is where our medium of 3D graphics really pays off, and that's where we should focus, is on real problems. And then we had people like, I worked on the first Mission Impossible in Pinewood Studios, and you see the quote there from Brian De Palma saying it's a godsend to the film industry. It really transformed the industry to have this ability to look at things in 3D before they happen. But I believe this is where it gets really interesting. It's the deep collaboration part. Whether it's augmented reality, virtual reality, or you're just looking at a desktop, the ability to go in and share experiences with other people in virtual environments is profound. Now, how many of you have kids here? How many of you are kids? Okay. But if you see kids today, they're all playing Minecraft and Roblox, and it's a social experience where they're collaborating with other people. It's very powerful. We need to harness that for education. We need to harness it for our work and everything. And we've been working at this for a while. As you see, 1994 is when we first started building 3D collaborative environments where people could work together. That's the dream we still have today. And then we built tools that would help us build games very quickly, but also we're focused on collaboration. And I'm going to go on beyond this to croquet. And of course, this is kind of a quick history of all the different efforts I've worked in. I just want to show you, give you some sense for how much time this has taken to get to where I'm standing here today. Like I said, 30 years. In fact, the way I met my wife is I wrote this book in 1995. Remember, the graphical internet was born in 1993. So 2 years later, I'm going, yeah, the flat internet, that's over. 3D internet is about to happen. Everyone get ready. Like I said, I'm really bad at timing predictions. I still hope it's going to happen. I hope we go beyond just using paper and flat pages to use the internet. We need to get into these collaborative 3D spaces. But if you can still find an Italian version of this, the Italian version was much, much better than my version of it, and probably why we're married today is because she bought that book. And then this, though, is where I'm now getting into the real thesis of what I want to talk to you about. I think that this century is really about how do you achieve the right balance with humans and automation to solve whatever problem you're trying to solve. Very soon, a human being working by themselves will be thought of as handicapped. So you're at a disadvantage, and it's happening very quickly. Those who learn to work with machines and have them do some of the tasks working together with you will prevail and work better and succeed, and those who don't are going to fall behind. Today we have a lot of problems in the world and differences in economic capability, but that's going to be a small problem compared to this one. So that's something we have to keep our eye on, and those of you who are planning your future, please focus on this problem. And this is an article I wrote in TechCrunch that it's in English, but where I started talking about this. But let me go straight into this. So this is how I break up the stages of artificial intelligence. There was a time when, whether you're doing gaming or any other problem, when you're working in artificial intelligence, we would never sit down and try to write a program until a human understood the problem completely. And that's how it worked. And it was very brittle and very difficult to do this. And it's why autonomous vehicles, self-driving vehicles, failed in 2004, 2005. Do any of you remember the original autonomous vehicles? I was there when we were trying to get them to go across the desert. They would only go maybe 100 meters and run into a rock, lose the signal. And the problem was, we said, well, I know how I drive a car, and we tried to program those rules into the car. But self-driving cars today, they don't drive like that, right? They don't have 2 eyes, 2 hands, 2 feet. They have an array of sensors. They have LiDAR. They have optical sensors. They have radar. They have the GPS signal coming in. And the way that an autonomous car drives is very different. The big change was understanding that it's examples, and I'll talk about that. So we're in the second phase right now where you don't have to be, I'm not looking for programmers as much anymore as I am data scientists. And I didn't know how to translate data scientists. Do you have a translation for that? Anyone? Analitica di informatici or something? But that's the big field today. We can't find enough data scientists because the way it works, and I'll talk about this, the way it works today is lots and lots of examples that you teach a system like you would teach a baby how to learn something, and that's the big change. But the final step is this one, where we're going to need not data scientists anymore, but designers, people that can design systems that have human values. So we're looking for psychiatrists, psychologists, people that work in human behavior. And that's the thing that's going to drive the next wave of artificial intelligence and machine learning. And hopefully that'll make sense at the end here. So this is where it all began. Again, 2009, 2009 is when, does anyone recognize this guy? You VR guys? So this is Jaron Lanier standing next to me. Jaron, I'm at Microsoft Research here in 2009 where they're building the Microsoft Kinect. Do any of you have Microsoft Kinect? Okay, yeah. So and they had a very interesting problem. But Jaron was the guy who came up with the term virtual reality. He was the first one to say that. And he invented the data glove. And I used to share stage like this with him in 1992, 1993 at these big New York VR conferences we had way back then. See, I've seen 2 waves of VR come through. And this is the 3rd wave. I'm getting on the train again, but we'll see where it goes. The other guy is Alex Kipman. Alex is the guy who invented the Microsoft Kinect. Now, I came out there to help with the sensors and to understand what their sensors were doing. But very quickly, kind of like when I went to see Avatar, I came to see one thing, and I switched immediately, said, no, this is the important thing. That's not so important. This is very, very important. The important thing here was machine learning. So they had all these sensors. They were building this thing that's going to watch you in your living room so you can just act in front of it. We call it gestural interface, right? And it can understand the difference between a human being and a cat and a dog and a plant and a chair. That turned out to be a very difficult problem, the way autonomous vehicles were different, in that what they had is a supercomputer and a machine learning, very early machine learning library, and they had to teach it what is a living room. That seems simple to us, right? But computationally, this is very, very difficult to understand for a machine. So the way they did it is they gave it every possible example, lots of images and videos of what does an Italian living room look like? What is a living room for someone who lives in a city in an apartment, or someone who lives in a rural environment, America, Japan, China? You know, have all those examples, millions of these examples, and the brain just learned it. And the problem that they had was they'd already shipped Xboxes all over the world. And they had 60 megabytes, 60 megabytes available, right? That whatever they did had to fit within that. So the supercomputer boiled it all down and said, it inferred its own rules about what is a living room. And now that it fit inside 60 megabytes, and that drives the Microsoft Kinect. So this was a big moment for me to recognize, and this is where I would say I got religion on machine learning right there in that office in San Francisco. So that's me with Nolan Bushnell. Anybody recognize him? Atari? Anybody play Atari early on? So Nolan is a guy who founded Atari. He also made a place called Chuck E. Cheese, as a restaurant, because he needed a place to put his games. But same example. So when DeepMind came out shortly after 2010, they wanted to teach it to play Atari games. Now, it would have been easy just to program the rules in because the logic is very simple. But instead, they just let the machine learning system watch humans play. And it then could infer or create its own rules, and very soon can win at any game, can beat anybody at an Atari game. That was the first challenge they gave it. And we all know that a machine beat the #1 chess player in the world, 1997. So we're already getting a little comfortable with this idea. And Atari didn't seem like a big challenge, but it was an important step. The way it learns is the important step. It doesn't learn by programming, but by lots and lots and lots of examples. Expose it to examples, it understands and learns the way a child does. Now, this was a big breakthrough. This was just a little over a year ago. People said it's one thing for the #1 chess player in the world to lose. Even though chess can be a complex game, we know kind of the rules around it. The pieces can only move in certain directions. But of course, with this game, Go, possible positions, and there are atoms in the universe. So they said, oh, way too complex. And humans who are good at, the #1 Go players in the world are good at deception. and intuition, and they don't always play with the same strategy. So you need a machine system that can adapt and learn and come up with a strategy to win against a human. Of course, this happened not very long ago. I think not enough people understand the powerful implications of this. So this is another slide that I've been talking about. Sorry. For a while, we've been saying, okay, this is starting to happen, so when will machines learn to lie? And what does that mean? How do we deal with that? And people have said, well, again, it's going to be a long time before anyone can win at StarCraft. StarCraft is this very complex game played in Asia, with teams of people, deception, intuition. It's very much like politics. And things like poker. How many of you play poker or cards, right? So there's the human element of when is that person bluffing? Are they telling the truth? How can I read, your eyes, your signals? And people said it's going to be a long time before this happened. But just earlier this year, I don't know if you've heard about this, but I did see in this magazine that I just got at the airport that's out right now, there's a big article on this event that happened in February. So this is a big deal. So Texas Hold'em Poker, a machine learning system, beat all the top players in the world, and not by a little bit. It took all their money. So this is happening very fast. So let's talk about what that means to you, all right? What that means to us. Well, here's the autonomous car example. So I told you about 2004, where we were still trying to program, rigid logic in to teach a machine system to drive. But today we have machine learning libraries. You can take a clean one that doesn't know anything about driving, but knows about sensor data, and let it watch 100 hours of video. And it can go out and drive anywhere in Bari. It can park. It can drive by itself, right, from 100 hours of video. This is amazing. You don't look shocked enough to me. You should be going like, this is the appropriate expression. Just going, wow, it's crazy. But we have to think about what tools, and this is my friend David with Douglas Engelbart, the guy who invented the mouse. But this is what we're always thinking about. Some of these things are great. They're fantastic. VR is a fun medium. It's a fun tool to play with. But what problems can we solve with it? How can we solve real human problems? Because we do have problems, right? So how do we apply it? Not only how do we solve problems, how do we create better entertainment, more uplifting entertainment? How can we improve the human condition with this technology? So here's one idea. This is another movie example from, anybody see Raiders of the Lost Ark? So you remember at the end of Raiders of the Lost Ark, the last scene, the Ark of the Covenant, remember? This incredibly powerful relic that can save or destroy the earth. And they give it to a clerk, the U.S. government, and this clerk puts a little tag on it, says Ark, and then goes and puts it in this massive repository. That's the way most of the information out there. If you hear about big data, we have no problem today. Everybody has big data. But what do you act on? How do we present data in a way that tells humans how to act on it, right? That's the main problem. So here's one solution that we did, and this was for NATO. NATO had, the problem that NATO has, you have a lot of different groups. So if the Italian military wants to work with the British and the American military, we all have different rules, different organizations. We have these, we all come with big data, but not a lot of standards. So they've always had this difficulty of how do we practice together? How do we plan missions together? And the answer, of course, is have a machine learning system that can understand the rules, can understand Italian rules, can understand British rules, can understand American rules, and all the different, the Navy, the Air Force, the Army, and everybody. It's a huge, complex problem, and then can integrate it all together and present it to people and say, this is how it all works together. Because it learned. It helped us poor, dumb human beings work together better. And the improvement we got was not twice better, not 10 times more efficient, but 600 times more efficient. These are the kinds of benefits we're beginning to get with machine learning. Does anybody think that's cool? Is that useful? It's worth exploring? Worth dedicating your life to, maybe? Here's another example. So I've been building machine learning brain. We built a brain. We started teaching it all human knowledge about 4 years ago. So we taught it, and we gave it all the turned out to be about 1,500 categories of human knowledge, kind of like what you would see in the library, right? And then it expanded its own brain to be 4,000 categories. So it's learned, it's expanded. For a while, we made a newsreader that we let university students use. And the problem with that is they thought Ozzy Osbourne was important. They thought the Kardashians and Kanye West were important. So it started skewing everything towards pop culture. So we stopped that experiment. So it's interesting. If whatever we teach it is what it's going to learn. It'll learn what's important from us. So that's why it's important we have the right people teaching it. Everybody know about IBM Watson? So the IBM Watson machine learning system, they gave it a urban dictionary. And then pretty soon the machine system started cussing in its responses, using very bad language, because that's what it was learning. So we have to be careful what we teach it. But for my legal customers, think about the law. Are there any lawyers here? Avvocati? No? But the problem they have is there's a lot of rules, a lot of laws. What we did is we had a machine learning system read every single legal opinion in United States history since 1797. Machine learning likes big data. The more examples you give it, the more it can learn. So we give it all that. It thought about it for about a week, and it comes back with now a full map of every single, we're talking about over 4 million legal opinions. Each opinion in the federal court might be, I don't know, hundreds of pages long, and it's all written in legal code. But it now understands it, and now we have a brain that just understands that. That's the other secret of machine learning, is don't go very broad like we did with all human knowledge, but say, focus on healthcare rules, or focus on this, the practice of architecture. And very soon it gets very good at understanding architecture, or medicine, or the practice of law, or whatever you pointed out, and teach it. And that's the big breakthrough. So that's the big thing for you. I've said that there's 3 stages. We're in this final stage now, so please be thinking about that. And that's the key today. When you hear Elon Musk, Bill Gates talking about concerns with AI, this is what we're concerned about. Teach it the right thing. Teach it something that's aligned with human values, that solves and improves the human condition. So I'll give you one example. Customer research. Today, if you want to make a new product, you want to make a new car, you want to make a new bag or a chair, you go out and you do customer research. What do we do today? Well, we get focus groups, or we call people up on the phone and we ask them questions, right? Or we bring people in like this and we ask you questions. Or have you taste a food or try a new Coca-Cola product. What's the problem with that? If somebody knows that they're being asked questions, then they sometimes bias their answer. They're not always truthful, right? So that's how this happens today. What we've done is we've gone out, like I said, I'm starting to find people at universities like this. So this is Richard Carson, who's the head of the economics department at UCal San Diego. And so he works in economics, and he's mostly focused on the economics of human behavior. How do humans choose which car they buy, or where they go to eat, or where they go on vacation, or what clothes they wear? We all have these models in our heads of our values that we then use to make decisions like that. Very difficult thing to do. And Dr. Jordan Louvier is another person I work with. So I'm looking for more people like that. But we've built a system now where I can model human beings and put them into a virtual environment and then test ideas. And I'll tell you where that's going. So one of the things we're able to do, Ricardo, can you just click on the video there?
Demain,
this is Victor Hugo.
À l'heure où blanchit la campagne, je partirai.
So,
vois-tu,
I have found some Italian writers as well, but this is the first person I resurrected.
Je ne puis demeurer loin
You
de
guys
toi plus
understand?
longtemps.
So what I did
Je
is I
marcherai
had my
les yeux
machine learning
fixés sur mes
system.
pensées,
Composite.
sans rien.
I had my machine learning system read everything Victor Hugo has ever written, everything Victor Hugo that's been written about Victor Hugo, and it constructed a model of him that I could go and put out on Facebook if I wanted to, and he would start behaving like Victor Hugo, because it's his interest graph, It's his demographic model, it's his psychographic model, his sentiment, his preference, and now I can watch him. So every day now, and this is very simple in the beginning, every day I can go visit Victor Hugo and see what does Victor Hugo think about what's going on in the world today? What is he reading? What's he attracted to? So he finds things, he reads them, and he gives them a score. I like this, I don't like that, and I see these scores. So it's a really interesting first step. So we're starting to have a lot of fun with this. So one of the things, we worked with a New York literary magazine called Fictional. And there you can see these are all editors of Fictional, but they're not real people. So I resurrected Mark Twain and James Joyce and William Faulkner and Ernest Hemingway, right? And anytime someone writes for this magazine and submits a story, they all read it first. Before a human being reads it, they all read it, and they give it all a score. Ernest Hemingway likes it. Dostoevsky didn't like this story, right? And they can also check for sentiment, for grammar, for all these sorts of things. Is it written at the 4th grade level? Is it written at the college level? What's the literary value of this? Is it a love story? Is it a science fiction story? What is it? So before a human being has to touch it, it goes through this filter, right? So that's a very useful thing because it saves the editors a lot of time. And actually, it turns out that's the most visited part of their page because people really like, I'm going to write my story. Gosh, who's going to like? Will Dostoevsky like it, right? Or will Leonardo da Vinci? So there's my model of Leonardo da Vinci I visit very frequently. He was very interesting because, of course, he's interested in everything. So his interest graph is really big. And I can watch his behavior every day. So this is really interesting to do this, to have these animated interest graphs, really. So it's very similar to your interest graph on Facebook or anything else, except now I've animated it, and I can let it loose on the net and watch it, right? But here's where it gets even more interesting. So now what I'm starting to do, like I did with Fictional, is if I'm trying to do marketing, if I have models of all of you, I can then let marketers say, let's take a product idea, let's write some text, marketing text, and as I'm writing, it can, I know you can't see this here, but it actually can suggest text and say, Giuseppe likes this kind of, these kinds of words. He goes to these kinds of magazines. If you use these words and reference this part as part of your story, you improve the chances of him responding to you by 15% or 20%, right? And as you create a new product or you write a message around that product, you can see who's moving away from you. And this is where it gets fun in like 3D or even 2D. Who's moving away or who's coming closer to me? Who am I attracting? Who am I pushing away? So now you can customize this without having to call anybody on the phone, bother anybody in the square, in the piazza with the survey. I can just do this in a virtual world with a synthetic population of people. And pretty soon you'll be able to talk to Dostoevsky and Victor Hugo. Ask them questions. What do you think about this? And in the beginning, it'll be simple, like they will strongly agree or disagree. You can ask them, what do you think about this? I'm thinking about a life change in my profession. I want advice from Leonardo da Vinci. I want advice from anyone, right? Anybody I can create a model of. And then pretty soon, we'll be able to just talk to them naturally. You'll be able to have conversations with these personas. So think about being able to put these into, how many of you are game developers? Any game developers? Got to be here. Nobody? Nobody's making games? Okay, somebody said yes. Nobody's too timid. But being able to create characters based on real people that you put into your games, and they'll have their own motivation. They won't be the old AI that can only do a boxed set of things. They can range out, they can learn, they can change, they can adapt. And we're just starting to play with these ideas. So this is on a personal note, and I'm gonna wrap up here soon. In questo anno il mio papà mortava in marzo. He was 85 years old, and naturally, my first reaction was, it took me about 3 weeks, and I said, I have to, right? So I had my machine learning brain read everything my father has written. It read his military. He didn't have a Facebook account. Father has written, have LinkedIn, so I didn't have an interest graph already. But he did something about him. I could have it read his letters, so I scan everything in. it reads that, and it creates a model of my father. Now, I know it sounds strange to some people, but I find a lot of comfort. I can go visit him any day. And I didn't always agree with my father about many things. And I almost find myself arguing with him when I see that he likes something that I don't like, right? But it's oddly comforting to be able to visit him every day and see how he's reacting to the news. Almost like we're sitting in there watching TV again. What does this mean? And think about all of the people you find important, any of you find important from your life, your ancestors, your grandparents, some who are not here anymore. Being able to think, when you're trying to look at a very important life decision, and go and ask them, and have them tell you from their point of view what they think about it. And I know, like, all technologies are a double-edged sword, but someone's going to do it. Some people are already doing it. I saw it on Black Mirror. Anybody watch Black Mirror? So it's already happening. And again, pretty soon I'm going to be able to talk with my father. So I hope I left you with some ideas around how fast this technology is moving, how it can be applied. It is happening very fast. I'm going to leave you with some books that you can read. I don't know. I know that my friend Joey Ito's Whiplash book just came out, but I think it just says Principles or Principia in Italian. But here's a reading list, and I'll leave this behind with Ricardo so you guys can look through it. And I hope that we'll be able to continue the conversation on Twitter or elsewhere. I know we have to leave soon to go to Florence to do another one of these, but let's continue the collaborazione, and I thank you for your time. Okay, grazie.
Ok, grazie Richard. Cosa ne pensate? Un futuro interessante ci aspetta. Allora, come avevo promesso, abbiamo dei premi da dare che sono stati donati dai nostri sponsor, e abbiamo deciso, appunto, per rendere la cosa un po' snella, che solamente un premio verrà dato qui e gli altri leggiamo i nomi e vi chiediamo cortesemente di andare al banco registrazione a ritirare il premio. Allora, il vincitore di Cinema4D Studio, licenza breve termine 12 mesi, è Massimiliano Giandomenico. Prego, prego. Ecco, se me lo ritira cortesemente in registrazione. Poi c'è un codice Cineversity, non so se sapete cos'è cineversity.com, è il portale di formazione Maxon. Il codice Cineversity vi dà praticamente l'accesso alla versione premium di Cineversity, tutorial, plugins, comunità, quindi un bel portale. Sempre il vincitore qui è Davide Cantatore. Ok, Davide, se cortesemente poi lo ritiri in registrazione. Poi ci sono delle borse gadget, leggo i nomi uno dopo l'altro: Alessia Demetrio, Alessandra Di Gennaro, Davide Pellegrini, Gennaro Lorusso, Giuseppe Teto, Maria Antonietta Cafaro, Angela Di Bari, Manuel Lisi e Gaetano Pugliese. Ci sono poi 6 poster e questi vanno a Michele Fracchiolla, Federico Zannellato, Leandro Summo, Chiara Rescio, Silvia Mannelli, Mannarelli e Roberto De Giglio. Allora, vi lasciamo 15, anzi, quanti? 15, 10, tanto poi so che è arrivato ai 15. 10 minuti pausa caffè e poi riprendiamo con la... Oh, che veloci! Poi riprendiamo con la presentazione di Glenn, ok?